So in this video, you guys are going to learn how to divide polynomials using a shortcut method. That method is known as synthetic division. So your goal, you guys are going to be able to divide polynomials using synthetic division. Now, synthetic division cannot be used all the time. It can only be used when the divisor is a binomial. And more specifically, the divisor has to be a linear binomial. Now, what is a linear binomial? Well, a linear binomial basically means that it's in the form of x minus k, x plus 2, x minus 3. You can even look at it if it was like, let's say 2x minus 7. But the divisor can only be a binomial. So if it has like a trinomial like x squared minus 2x plus 3, you have to use long division to do that. So we're going to take this example of 5x to the third plus 17x squared plus 7x plus 3, and we're going to divide it by x plus 3. So the first thing that we're going to do in going about dividing this binomial using synthetic division is we have to determine the value of k. And the k basically represents the opposite of what's on the inside of that divisor. So as you can see, we have x plus 3. And so k is going to be a minus 3. Because in order for us to get an x plus 3 from a binomial that's in the form of x minus k, then k had to be a negative number. So it's always the opposite of whatever's on the inside of that of the divisor. So you put the negative 3 in the box, and you put the coefficients to the right of it. So we have 5x to the third, so you put a 5, 17x squared, you put a 17, and so on and so forth. After that, in order to start off synthetic division, you have to bring down the first coefficient, which in this case is 5, because you need a starting point. And then from there, you're going to take that first number that you brought down, and then you are going to multiply that number by negative 3 and put the result in the next column. So in general, whatever is in the box, you're going to multiply the first coefficient by that number and put it underneath the second coefficient. So 5 times negative 3 is negative 15. After that, if you're looking at the work that's already worked out, you are going to add the values of the second column. So 17 plus a negative 15 makes 2. And then you're going to multiply that number by negative 3 and put the result in the next column. So you're basically going through, you bring down the first coefficient and multiply that by negative 3 to get negative 15. Add, and then you're basically going to repeat the process, repeat step forward. So you're going to multiply 2 by negative 3 to get negative 6. You're going to do 7 plus negative 6, which gets 1. And then you're going to multiply 1 by negative 3, which gives you negative 3. So that's going to go in the last column. And then you're going to add those up together. And 3 minus 3 is 0. You add that last column and put the sum of that number in the last box. Now that last box does indeed represent something, and hopefully you're able to see as we have these coefficients basically serve as our quotient. So what we are going to do at this point is we are going to write the quotient, which is our answer when we divide the polynomials. And we begin writing the quotient by the power of x that is 1 less than the greatest power of x in the dividend. So if we start with the x to the third, then we're going to end with the x to the second. If we start with the x to the fifth, we're going to end with the x to the fourth. And the last number that's in that box represents the remainder. And so in this case, we have a remainder of 0. And so the quotient is going to be 5x squared plus 2x plus 1. So it may seem like a lot of steps, but to be honest, it's really just a repetition of the same process of just multiplying, bringing down, and so on and so forth. So let's look at this next example. We're going to divide negative 10 x to the third plus 83 x to the second minus 26x plus 6, and we're going to divide it by x minus 8. So now we need to take the divisor and we need to figure out what is going to go in our box. Well, k is going to be 8 because remember it's always the opposite of the inside. So if it's x minus 8, that means k had to be a positive 8. So we're going to put a in the box, and then from there we're going to put our coefficients to the right of the box. All right, and so we're going to have negative 10, 83, negative 26, and 6. And then we're going to draw our line, so that way we have a nice spot to put everything. And of course, we're going to bring down our first term. No matter what, you always bring down your first term because you need a place to start. So when we bring down the first term, which is negative 10, we're going to multiply that number by what's in the box. So negative 10 times 8 is a negative 80. Then we're going to add those numbers up to get the sum. So 83 plus a negative 80 is a positive 3. We repeat. 8 times 3, we're going to put that number underneath the negative 26. So we have negative 26 plus 24, which is a negative 2. Then we're going to multiply 8 by negative 2 to get a negative 16. We add that up, and we're going to get a negative 10. Now, negative 10 is in the other box, and that negative 10 does indeed represent our remainder. So now we got to write the quotient. So those coefficients, remember, we start with the exponent, the largest exponent, and then our quotient is always one less than that. So our quotient, using these coefficients, is going to be negative 10x squared plus 3x minus 2 with the remainder of negative 10. And as you can see, that is, of course, written as a polynomial notation, which is what we want to write it as negative 10 over x minus 8, which we see right here at the bottom of this screen. So now let's look at the next example. Here's one that has a missing term. We have 6x to the third plus 12x squared plus 9. If you notice, it's missing its constant term. It's missing its x term. So whenever you're missing a term, you always, just like before, you want to put a 0 in that spot. And since we're only dealing with the coefficients when we do synthetic division, you're only going to put a 0, not necessarily a 0x like you would if it were long division. So we start by breaking down our first term. Let me add in our box here. That's going to be from our remainder. It always goes underneath our last number. So we bring down the 6 and then we multiply. 6 times negative 2 is going to be negative 12. We put down underneath the positive 12 and we add to get 0. Then we multiply. 0 times negative 2 is 0. And then we add to get 0. And then we multiply 0 times negative 2 to get 0. And finally, we have a remainder of 9. So remember, we always write our quotient as an exponent that's one less than what we start with. So if we start with x to the third, then it's going to give us an x to the second. So our answer is going to be 6x to the second plus 9 over x plus 2. Remember, it's always written as your remainder divided by your divisor. Now, D is a little bit different because it represents a polynomial or a division where the divisor is not in the form of x minus k. It's actually in the form of like ax minus k, where there's a number in front of your x. So you do have to do these a tad bit differently. It's only different in two different spots. So to start, you have to figure out what goes in your box. So go ahead and set that divisor equal to 0 and solve. And whatever number you get for x when you solve, that's what goes in your box. That's what you're going to end up multiplying all your numbers by when you go through synthetic division. All right, and just like before, you write the coefficients of your dividend. And you proceed to divide. So you bring down the 6 and you multiply. You got to do 1/2 times 6. So it's really what's half of 6, which is 3. You put that underneath the 15. You add, so you get -12. You repeat the process. What's half of -12? That is a -6. You add. You get a 54. And then you do it again. 54 times 1/2. You get 27. And you add. And then your remainder is going to be 5. Now, this is where the other part is a little bit different from doing synthetic division. Because you're A, you actually have a number in front of your X, you're going to have to divide every coefficient of your quotient by whatever A is. So since we had 2x minus 1 as our divisor, and we have that number in front of the X is a 2, we're going to divide 6 by 2, -12 by 2, and 54 by 2. Only the numbers that are in your quotient, never the number that's in your divisor. Because it's pretty much already getting divided by your divisor when you write it as polynomial notation. All right? So let's say your divisor was 3x minus 4. Well, then that means you want to divide all the numbers of your quotient by 3 because it was a 3x. So whatever A is, whatever the number is in front of the x, that's what you want to divide by, and only the numbers of the quotient. So when you divide 6 by 2, you get 3x, and it's going to be a square because you always do one less. And then -12 divided by 2 is a -6, so then it becomes a -6x. And then 54 divided by 2 is 27, so then that's going to be a plus 27, with, of course, our remainder of 5 over 2x minus 1. And this was actually going to give you the actual dividend when you multiply the quotient by the divisor, because 6x squared times 2x is actually what's going to give us a 6x to the third. Think about it. Don't forget that rule. Quotient times divisor plus the remainder, and you should get your dividend. All right. So just a few things before we wrap up. Remember, so there's a few things when you're dividing polynomials using synthetic division, just like before. You want to make sure that your polynomials are in standard form. Just like before, all your terms must be included. So if you have an x to the fourth, then you must have an x to the third. So if there isn't an x to the third term, then you want to make sure that you write a 0 for any missing term, just like before. And you repeat the process of multiplying and adding until you determine what your remainder is. So you multiply whatever's underneath the line by whatever's in the box, and you add it to the next column. And then, of course, remember, you want to write the quotient with a power that is 1 less than the greatest power of x in the dividend. So if you start with x to the third, you want to end with x to the second. And lastly, the last number represents the remainder. Now, this is one thing that I haven't talked about. If the remainder is 0, if you get a remainder of 0, then the divisor is a factor of the dividend. That means whatever you got for the quotient goes in evenly into the dividend, and that's why you have a zero as a remainder. So that actually serves as a factor, which is something that you're going to experience later on down the line when we get a little bit deeper into polynomial functions. But that is how you divide a polynomial using synthetic division. Remember, it cannot be used every time. It's only when your divisor is in the form of a linear binomial, like an x plus 2 or 2x minus 1. And that's when you can divide using synthetic division.